I hope you're feeling well. I'll take that as a yes. Okay, don't be anxious or anything. We're getting there. I want you to just look at this part of the board first. Okay, I'll tell you why. If you remember, I said for homework, last week, maybe Thursday or sometime, I said, try these guys. This one was interesting. If you look at the memo, you'll see it wasn't as hard as you thought. Because if you join A to O, it's a radius. And you know that a square has 90 degrees. So if you let that be X, which they told us to, and, you know, etc., you'd see that that would be X. So it was a very interesting question, the memo's there, but I just wanted to show you this. When I sent you the memo, if you remember, I just said, I'll explain that reason on Monday for the last one. It's very, very rare. I don't think I've ever seen it in my 23 years of teaching, but just if you get a picture where in the givens, you notice I don't say O is center. You might say, Mrs. Holmboe, it looks like it's center, but I did not tell you anywhere. In fact, I'm saying, can you prove O is center? Okay, but what am I giving you? I'm giving you AD equals DB. So in other words, D is the midpoint of chord AB. And I'm also, at the same time, giving you that the line OD is coming in perpendicular to AB. So we would call the line OD, it is called a perpendicular bisector. So that is a line that comes and bisects, which means cut in half, another line, but simultaneously it's perpendicular. And if you get a line that is perpendicular bisecting a chord, that is your reason. It's a kind of a converse why O would be the center. So for this, you would just say O is the center. Reason would literally, you say perpendicular bisector. So you they'll even accept perp bisector. Okay, so we've never looked at that reason before, but I'm just saying that is if you're given a line that is perpendicular to the chord and bisects the chord. Hence, going backwards, O would be your center. Okay, so I just wanted to bring that to your attention. Now that I've brought that to your attention, I want to go back to what we did on Friday. Now, I wasn't having the best day on Friday, and it's not that I did the proof wrong. I just did it where it looked a bit worse. Normally what happens is they don't draw in the chord. I think by drawing in the chord, I made the proof harder than it actually is, because it's not a hard proof. If you were given this proof where they say given, please take note, they say is the center of the circle ABC. Remember, that just means the points there lie on the circumference, which means they are concyclic, and concentric if points lie on the circumference. Prove that angle AOB is double 2 times angle ACB. Now, do you remember I did this proof? I just want to start the lesson to do it one more time because there were some of you who missed it. So you've got over these proofs, draw a construction. So you would start from C, you would join CO and extend it to any letter. Let's just go point P. Just make sure that is in the circle. So I'll do it again, and this will be a neater version if you want to then just quickly screenshot it. So my construction, I would just say join CO, and you can say extend, or remember a synonym is produce. So choose the one you like best. I prefer extend to P. So that would be your construction. Okay? And then if you remember, I'm just saying to on the left, you have a little triangle here, which in red. And because this to this is a radius, and so is that, you could basically say it's an isosceles triangle, which it is. And if you look at the triangle on the right, just so you can see, okay, that pen doesn't work, goodbye pen, just so you can see, we'll call this the blue triangle. Whoa, that was an ambiguous dot. He didn't know where he belonged, but now he knows. He's in the triangle on the right, okay? This would also be an isosceles triangle because that is a radius and so is that, which means you've got two isosceles triangles. Now, if you remember for the proof, this is how I said I do it. The textbook doesn't do it like this, but it's very easy to remember. So you literally write proof. So after your construction, which has to be drawn, you're going to say let angle A equals to X. All right? Now, put that in your diagram. If angle A equals to X, oh, then we better go, this is C1 and this is C2, and this is O1 and O2. Because through my construction, we have not bisected the angle, which means cut it in half. We've just split the angle. So we must refer to angle C1 is just this piece, ACO. That would also be X. So you would just tell your examiner, therefore, you could go angle C1 hat equals to A hat, which equals to X. I, for the reason, would go angles opposite equal radii. Remember, you're not allowed to say isosceles triangle. Then if you look at the triangle on the left, this red side is being produced, which means this angle O1 is your exterior angle of this red triangle, which means it equals the sum of the opposite two interior angles. So we can conclude that angle O1 is going to be 2x, and it's just because of exterior angle of, now I'm going to just tell you which triangle. I'm pretending it's red triangle CAO. You can put those in any order, OAC, whatever, whatever, whatever. Then if you remember, I then just say also or similarly, I'm just going to say let angle B equals to Y. Put it in your diagram. Therefore, degree C2 would equals to Y. Therefore, C2 hat equals to B hat, which equals to Y. Same reason here, huh? Angles opposite equal radii. Okay, cool. Then just like we did in the triangle on the left, a triangle has three sides, and of the triangle, the blue one, the red side has been extended or produced. So this angle here, which I'm calling O2, is the exterior angle, which means it adds up to the sum of the opposite two interior. So that angle O2 will be 2y. So therefore, angle O2 equals to 2y. Why? Because exterior, oh, that was meant to be angle, not exterior angle. Exterior angle, we're talking of triangle. Which one? The one on the blue. So let's just go COB. Okay? Now, to end off, just watch, look carefully. We specifically want to prove that angle A is double angle ACB. So degree angle AOB equals, look at it carefully, degree is 2x plus 2y. Degree that angle AOB is the 2x plus 2y. So angle AOB, oh, dyslexia, all right? If you factorize this and just take out the 2, you have 2x plus 1. And if you look carefully, angle ACB equals to, now look carefully, x plus y. Do you see that angle is x plus y? So it's 2, and then you just replace your x plus y with CB. If you think about it, that's exactly what they said. AOB, apologize, 2 times angle ACB, okay? And it's little errors that I'm making along the way. But anyway, it is correct. There's no further reason needed, and that proof is a very, very common proof. Now, that is something you have to L-E-A-R. Like that word, it means you learn it off by heart. I will be sending it, but I do want you to acknowledge that that could be the proof for 5 marks that you get exam at the end of the year. It could prove you get your matric final. Okay, so I'm going to you all the proofs that we've done so far, but I just want you to be just before we look at our homework, I want to just quickly put another diagram on the left. I'm sure I can still squash it, okay, because it's actually the same proof. Just watch carefully. Okay, now everyone watch this. So there is another circle. Now, what I'm going to do with this circle, just watch, don't copy, just watch. We're going to have O is sent with you. We're going to have a radius from O to A. We're going to have radius from O center to point, I think I called it B. Let's just make sure it's the same. And then I joined a chord from A to C. And if I join BC, that's also a chord. Right. Now I want you to listen very carefully. That's not the best picture, but O is the center. That's O. Now, do you all agree that this angle here is called a reflex angle? Bigger than, 180 degrees, but smaller than 360. Smaller than 360. Okay, and there is your acute angle. Now, I'm going to prove to you with the exact same proof that the reflex angle at center is also going to be angle at the reflex angle at the center will be double angle at the circumference. Okay, now I'm going to prove that to you, and I'm just going to take away the word reflex, and I'm going to take away the 2x, and they would not put a line there, but what they could do in your exam is draw this diagram instead of this diagram. They will say O is center of circle, and they're still going to say prove AOB, or they might say prove reflex angle. So this AOB equals to 2 times ACB. So you see it's actually the same thing. Yeah, I think here they'd have to go reflex. So let's just write that neater. So if we're doing the diagram on the left, then I'm going to go reflex. Right, now, it's exactly the same. Just look at this and see how exactly the same it is. Okay, we need to draw a construction. Sorry, just looking for my red pen. There we go. My red pen has a green lid. That confused me. What was my construction here? Do you remember my construction was to join CO. Remember that's O. So join CO and produce or extend to P. So that's exactly the same construction. Then I said, let angle A equals to X. All right? So I'm just going to go here. Let angle, say, look, let angle A, I'm not even going to rewrite it, equals to X. Now, because this is a radius and this is a radius, then we have to go C1 and C2. Because we have not divided exactly in half, please note, but we have broken angle ACB into 2 angles. They're not necessarily, and they're actually not going to be the same. But you agree that would also be X, C1. Why would that be? Because angles opposite equal radii. So look, C1 would equals A, which is X, same reason. Now in the triangle on the left, this is the red triangle, if you want to think about it. It just looks slightly different. But if this side is produced, then you agree this angle, I think I'm going to have to name it O1. It's called that angle O1. From there to there, do you agree that would be the reflex at the exterior angle, sorry, of the triangle, which would be the sum of the opposite 2 interior angles. So Where we go, therefore, look here, O1 is 2x, exact same reason, exterior angle of triangle CAO, exactly the same, all right? Then if you remember, I said similarly, I said let angle B equals to y, so nothing's changed, look, there it is. And then if you remember, I said therefore C2 is equals to B because of angles opposite equal radii. Well, look, in the blue triangle over here, do you agree that that is a radius? That is a radius. So yes, that's a true story. So C2 equals to B because of angles opposite equal radii. And then this here, let's call this angle O2. This here becomes now the exterior angle of this triangle because this red side has been produced. So it would add up to 2y. So nothing's changed. O2 is 2y, exterior angle of triangle, COB. And then you can see if you add this angle here up, you still get angle AOB, but we talked about the reflex angle, AOB, this one, is 2x plus 2y, which is 2x plus y, and there's your x plus y. So don't rush and copy this all down, because once this lesson is over, I've got the first two proofs that we did last week. Remember, the one was, if I gave you a line perpendicular to a chord, we had to prove that it, I think the first one I've given you, sorry, I gave you a line from center to midpoint of chord. We had to prove it was perpendicular. On the right, if I give you a line from center perpendicular, we have to prove it bisected. And there is the proof I've done today first with this diagram. And then here is the proof I did today here. So it's all neatly in one, I've put it on one page. You might notice in the book there's another one where it's slightly on the side. For now, I'm going to leave that. I asked Miss Brownbull once, and she's a good friend of mine from Parktown Girls. And I said, Miss Brownbull, that third variation of angle at center proof, I said, do you think they'd ever ask it? And she said, nah. But one day, I think it'll be easier when we're in our classrooms as a recap. I will show you, again, it's almost exactly the same. It just ends slightly differently. But I do not want to do that on camera. All right, let's now go to your homework. Now, I said in the textbook, I only asked you to do 4 examples, and they're all going to be sort of using this. And the reason I didn't want you to go on to the next one, it brought in this. But now you know, so we can carry on as a learning channel, that the reflex angle at center is also double the angle at the circumference. Okay. Look, I left out your grade. How sad is that? I'll put it back in now. All right. Let's get rid of that. Okay, to speed this up, I'll do 2 at a time, because what you had to do for homework, guys, was easy. Like you can't actually get easier than what I gave you for your homework. But let's just look at it and put in your 11. Okay. If you weren't on the group on Friday, then you might not know what your homework is. So I just said, go to page 1216 and do, I said, A up to D. Now listen, whatever you do, you're not allowed to draw in your textbook, okay? This doesn't belong to you, it belongs to the school. Excuse me. I sneezed. It doesn't mean I have the coronavirus, trust me. But anyway, what I just did. Okay, so I've just said you are a hypocrite. I said you can't draw in your textbook, and by sneezing and, okay, but you're going to say that's the wrong color. Okay, that was an accident. But what I'm saying is, if you do need to, in any way, work on the diagram, you can use lightly a pencil. And when you finish, then please erase it. So the student who comes up next year from grade 10 to get your book can't see the answers, okay? One year we found a student who had done everything with highlighters, and our HOD actually called him back to pay for the book because he basically ruined it. Defaced it is the word I was thinking of. Okay, so now your homework, you should cruise through it. Hey, look how easy these were. All right, let's just quickly draw you. The first one was something like this. It's quicker. It's easier if you have the textbook in front of you. Guys, I went into my old classroom on Friday just to reminisce. And I saw about 9 grade 11 textbooks sitting there in a pile. Now, just quickly, I want to say to my class, I've already had one student, I won't name him, who said he's left his textbook and he needs it. So if I don't forget, I must just write here a textbook on my hand. I'm going to go to school today because I've still got to teach my matrics, and bring his to my house because I'm not far from Greenside, and then we'll liaise that he can come past my house and just I pass it through the gate. If there's anyone else who knows that their textbook is in my class, you can SMS me and say, ma'am, can you do the same with me? But then I'm not going all over to your houses. My house is a 2-minute drive from Greenside School, all right? It's just closer to Barry Herzog Road. Right, anyway, come into your homework. Number A, and we're doing exercise 2. Please take note, they said, as I said, you never assume, they said right there, O is the center of the circle. Given. O is the center of the circle for all of them. Okay, so the instruction was actually right up there, and they said solve either for X and or Y, but with reasons. Okay. And if you look at the first one, they said this is 62 degrees. Let's just put in my vertices. Okay, so that point on the circumference is A, that value is B, and this value here is C. All right, and then they put here X. Okay, so as long as you know your work, it's easy because this angle is double this angle. So if you double 62, okay, well, if I double 6, I get 60, I'd get 120. So that would be 121. Wait, I'm being plotted. 62.
Ma'am,
yeah.
your video's gone away.
Can't hear you.
Your video, it's gone.
Gone. Yeah. What's happening?
Here we go. It's back.
There. Back. That's magic. Okay. Am I right that if you double 62, 2 2s are 4, 2 6 are 12, then the angle at the center must be double, not the other way around. Remember, center. So angle X would equals, remember to put degrees there, and you go angle at center equals 2 times angle at circumference. You cannot abbreviate it anymore. I've already abbreviated it. The textbook is happy with that symbol being angle equals 2 times angle at circumference. And that would have been 2 marks. Do you see what I'm saying? In the second diagram, what did they do with the second diagram? Okay, O is opposite, still O is center. Let's just take that away. Okay, this is number B. They put A here, and they joined, that's a radius. Then they put B. Wait, am I doing the right one? Yes, sure. No, I'm doing the, you know what, I'm looking at the wrong diagram. Sorry, let me just rub that up. That's not what they did. Sorry, I'm looking at B, okay? A was here, A. And then they had a chord, because it went from A, not to the center, so it's not a diameter. There's point C on the circumference. Then they had another chord from C to B. Again, it's not going through center, so it is not the circumference. Look, you might say, oh, it's almost. I'd say, yeah, almost, but not. Then what did they do? Then they drew a radius from O to A, and they drew a radius from O to B. Okay, that's not a very pretty picture, but hopefully you try to do that. Anyway, they 24 degrees, and then they put, oh, you know what? This was not exercise 2A, this was exercise 4A. I'm so stupid. Exercise 2A was actually, they gave us that. Sorry, I was looking at the wrong exercise. Guys, I asked you to do these four. I was looking at these, I'm mixing these all up. So even easier, they say this is X, there, that's 60. So it would just change my answer. If that's 60, then the angle of the circumference would be half. So X would be 30. But luckily the reason is the same. Okay, so if they give you the angle at center and that same arc is subtending, it's going to be the same arc, angle at circumference, then you know the angle at circumference is going to be half. Okay, so now they've given us the angle at the circumference for the real B. So I know that the angle here, if you want to refer to this 01, this will be double. So this one would be 48 degrees. All right, so that was X. So I'll just do this one here. In this example, X would be 48 degrees. Remember, they gave us that. We had to determine X. So we doubled it. And the reason is the same. Angle at center equals 2 times the angle at circumference. Guys, when you practice at home, don't be lazy and say, I know what my reason is, therefore I'm not going to put it in my work. Because I promise you, the more you write it, the more it's entrenched. Right, let's quickly look at, I'm going to rub these out because I can always send you the memo for these. Let's just look at, we've got C and D, and then we can move on with the rest. How many minutes have I got left?
You've got 10, 11 minutes. 11 minutes, ma'am.
Perfect. Okay. So I must just keep, I'm doing exercise 2, guys. Now I'm on exercise 2C. So if I do the wrong one, shout at me. Okay, there's my circle as best as I can do it. Now with number C, what they did was they put in O, given, please note, given O is center. That hasn't changed. Okay, and they drew me sort of a radius from there to there. And on that circumference, they put that was A. And this point here is B. And then watch carefully as I do it. This is the arc you're looking at. You see that arc? Now watch. That same arc is subtending an angle at the circumference. The only thing that makes this ever so slightly harder to see is instead of being vertically up, they've just sort of brought it a little bit on the side. Okay, sorry, don't want to go over my circumference there. So what did they ask this time? They said, what is that angle? All right, so if this angle, so by the arc AB, is 10 degrees, go down with your fingers, then we know it's double at the center. So do you all agree X would be 20 degrees? It would be double the angle at the circumference. Reason, you're going to get very sick of this reason, angle at center equals 2 times angle at circumference. Okay, 1, 2. Okay, so be always above it. Always just use your fingers and kind of go, you know, maybe over there. Okay, let's quickly look at number D. Just got to draw it quickly. I'm going to leave my reason there. I'm being so sneaky, but I have a big suspicion that it's going to be the same reasons. So obviously you would never do that in a test. I'm being cheeky, okay? But what they drew this time is they said, given O is center, they drew us a radius from there, up there, and there to there, and that's a straight line. This is number D, that was B, and that is A. So this is example, exercise 2D. We've now moved to page 117, just for interest. This is of our textbook, okay, 217. Okay, so this was B and this was A. Now, you all see that is the arc you must keep your eye on, right? We can call that angle O1 if you like. And then what they did is they've drawn a line like so to so and called that on circumference point C. So do you see, you've got your arc BA, it's subtending an angle at center, go back, that same arc is subtending an angle in the same segment. Remember, that's got to be, if I join that card in the same, it's called same segment. What did they give me? Time they said, okay, this is X, and this angle at center is 36. So in other words, you won't be able to see that. O1, they give me as given is 36 degrees. They would say determine X. Now, remember, the angle at the center is double the angle at the circumference. So if I half 30, it's 15. Half 6, it's 3. So it's 15, 16, 17, 18. Haha. So X equals to 18 degrees. Do not forget the degrees. And there's my reason. That's called multitasking. Right. Now, I said, the reason I said my lamb chops, I said don't do number E, was because you didn't know on Friday about the reflex angle. Okay, so if I now look at number E on page 217, okay, this time they said given, oh, I don't know why I keep rubbing that off. Is the right? So I'm look like something, and then there to there, which is a chord, and from there to there, which is a chord. And let's label it exactly as they labeled it on in the textbook. So now on page 217, I'm doing this example. So they went X, so they obviously wanting that, and they said that is 120. Okay, and given O is center, da 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 da. So do you understand? It would be double than that. So in this example, X equals 240 degrees. Now they will accept the exact same reason. I'm a bit OCD. I tend to write reflex angle at center equals. But guys, if you don't put reflex, you're not going to lose a mark. It's just, I've always been like that. I want to be more specific because there's two angles at the O, at the center. There's the acute one and there's the reflex. So I will always add that, but your textbook probably won't. Okay, so that was number E. So we know that that angle at center, even though it's the reflex, is double angle at circumference. So now, look, I could go on and on and on, but on this level, it's too easy. So your homework for tomorrow is going to be do, yeah?
4 minutes.
Okay, you're going to do F up to J, right? Exercise 2. You're going to go page 217. Now remember, if you write in your book, use a light pencil and then please erase it. All right, they get a little bit harder here, but you're going to do from F to J. Do them tomorrow. In the last minute I have, I would like you to do a bit of thinking. What I'm going to show you now is called a corollary. That was my plate falling on the ground. Now, if I draw you O is center, I just want you to think about this. We'll look at it tomorrow. And I draw a special chord going through that center. You all agree we know that is a diameter. Now, if this diameter subtends an angle at the circumference, I'd just like you to think about it. Would you be able to work out how much that angle is? Who thinks they know what that angle is? How much, the magnitude? Anyone know?
Ma'am,
I
I
say
think
that
it's
angle
90.
is 60 degrees.
It's not 60, it's going to
I
be
think
90.
it's 90, ma'am.
To agree that that is an angle on a straight line, which is 180. So the angle at center is double the angle. So that would be 90, right? Because that is a straight angle 180. But you've got to understand we've got a new reason here. So if you want to tell me angle C is 90, if you're given a diameter, you've got to say angle in semicircle. That is the reason that you've got to learn. Just think of a diameter creates two semicircles, one there and one there and one there. And we're just saying it's the angle in the semicircle. So if you ever see a diameter, always watch out for your 90 degrees at circumference. But that is a corollary of what we've done today, because the angle at the center is double the angle at the circumference. So I'm going to stop on that point, and I'll see you again tomorrow at 12. I still don't know what our time is yet for Wednesday, but I will let you all know tomorrow. Miss Kutter said she's only going to be letting us know, I think tonight or tomorrow morning, about Wednesday. So I don't know yet. But I love you lots. Take care.